Hey, awesome. Today I'm talking about a very requested topic, and that is using Git to sync your nodes and keep versions. Now, using Git is awesome. I'm going to talk about Logseq, obviously, but this will work for any text-based backend. So, for example, Obsidian, which also uses Markdown. Now, before we dive into the full video, I've split it up in a couple of sections talking about the Git basics. So what is Git? How does it work? It's going to be very high level, very visual. Then using that to do versioning on your local system, how to make backups using that same system, then using it for personal sync. This, however, will not include syncing to mobile devices, mostly because that's a thing in its own, but there will be links about that in the description. And finally, some tips and faults on how to use this if you want to do some type of team syncing. So if you want to use Git as a central repository and work with that with multiple people. So some limitations with Git, it's good to know up front. First of all, no syncing to mobile devices. I tried it, and on Android, for example, I had to use some text-based interface, and that was really clunky. iOS, I don't have an iOS device, so I can't test it. I am told that there's like better tools for it. I will put a link to some excellent documentation for using this in the description, but to me, like, it's much better to have the Git checkout somewhere and then use like a file syncing tool like SyncThing or maybe even iCloud and Drive, though those are a bit trickier, at least to me, to get like the full files across. That said, like, the solution I did was like I had like a server that did like an automatic checkup and then run the sync from there, and that gave me the benefit that if I had to fix something with Git, I could just go to the server and run full Git commands. Another important point to note is that Git is open, so like your nodes on your local system are readable by anyone that has access to that system or to that directory. And when you're using some of the sync solutions, I'm not 100% sure of Obsidian, but I know for sure for Logseq, their stuff gets locally encrypted before it gets uploaded to your like cloud storage system. Git doesn't do that. If you use something like GitLab or GitHub as a backend, then know that your nodes are just on their server, they're just readable, and if you don't lock down your project well, they're readable by the whole world. So those are things to keep in mind. You're taking like your own access to security. If you care a lot about that, then I would definitely be either syncing to your own system, your own server, and preferably on a disk that is encrypted when the system isn't on, so encrypted at rest. And last remark, the upcoming database version will initially probably not work with this. There is a mention of a two-way sync to Markdown files, which is what you would need to do like the Git sync. But my assumption is that when it hits, they'll first like try and get all the bugs out, get it stabilized before the two-way sync will arrive. Meaning that if you want to use Git sync, you will have to use the file-based backend a little bit longer, and you might just be able to play with the database thing. So if you're setting this whole thing up, keep that in mind. Now let's dive in absolute Git basics, and that starts with what is Git. And Git is a version control tool, so it's mostly developed for software development where you have code where you make changes and you want to be able to track back what you changed. This is very practical because that means that if you, for example, make a change and your code breaks, you can see like, hey, what did I change the last hour, minute, day, revert that, see if it still works, and then debug your issue. For nodes, it's less practical because while you have versions, you do not compile it into something that works. You just look at your nodes and see if they are valid. Still, being able to see changes over time, being able to go back or even to recover some data are good reasons to have Git as a backend, since the whole goal of Git is to never ever lose anything. Once you submit something to Git, if you put it into like the Git system, that change is there forever. You can't revert it. That's how it is set up. Well, is technically possible, but that's a whole different video on like rebuilding your Git log to remove a version change. Now let's start with what version changing means. So Git works differently. When you look at files, you usually think of it as like version 1, version 2, version 3 final. They're all separate files in your head and they all have like the latest version of the code, but that's not how Git works. Git keeps track of changes, and so that means that for Git there is no file in the system. Git is just changes going from there was no file to if I change change this, then this file is there. Then if I change that, then those things combined make that file. As you can see here, like combining all those changes gives you different versions, but you usually only care about the last one. And then the magic of computer power is what Git does. It just does all the changes after each other in very rapid succession to get you your final file. There's some trickery happening in the background there. That's way too technical to dive in right here. Given that change option, that also means that you have things like, hey, you can have multiple changes. Say I would make a change on my laptop and I would make a change on my desktop, or in practice, if you're working with a team, I'm making a change and Bob the cat makes a change. Those things will make different versions. So in this case, I get like an example where I'm saying like, hey, I got like 3B and I got like 3A. And that's a problem because, oh, how do you combine that? Now with Git, that's actually pretty simple because Git just needs to know how to stack those changes after each other. So it goes like, hey, these changes brought like 3B. And then if I add that other change to it, then that will get me to version 4. And merging is then the tricky thing that you need to think of, because with changes, that's much easier. If you have like 2 files and you want to merge them, then you have to like stick them together and then hopefully get it to work. And very often that resolves into conflicts, things that you have to read through. Anybody did any type of like sending out a document asking for feedback and getting 5 versions back and trying to mash those together knows what a pain that can be. So the change thing makes it totally different. When a Git merge happens, it just looks at changes and then it's like, oh, well, some changes are the same, so those I can just ignore. And some changes are like in a chronological order, and then they can just move it after. And you see that just slides straight into each other. Now, of course, the real world isn't as nice as that. So sometimes you have like a little overlap between change 3 and 4, and that means where a human comes in. But the big difference here is that all the other changes are already merged, and you only need to look at that change 3 and change 4 in this case and see like, hey, what's the difference? And then once you fix that in Git, that's like another change, and that means that gets stuck over it, and that's a change 5 explains how to merge 3 and 4, and there you have your end document. Change 1, 2, and 5, which is how to combine 3 and 4, and eventually you'll get your end document. So that's like really quick, very summarized version on why Git is different than like normal file syncing, which doesn't do these kind of tricks or keeps track of the actual changes. But the system itself is used in a lot of systems. For example, if you're working in something like Google Docs, it does exactly the same thing. It just keeps track of changes, and this is why you can work with 6 people in the same Google Drive document, because everybody makes a change, and the change is what kept track of in the backend at Google. So you make a change, somebody else makes a change, and it just said like, okay, these 2 changes were made. So only those things go over the internet. We're not sending documents up and down, and this is good to know because knowing the structure of Git helps a lot if you later want to debug problems, if you ever have issues with your Git versioning. I hope not. Most of the time it should be simple, but as you start adding more systems or making it more complex, there are chances, and at some point it might break, and then it's good to know that everything is there, and that the worst that you can have is that you have to open like multiple versions, so like places where changes happened, and that you can manually fix it. Luckily with nodes, it's a lot easier to figure out where the conflict happens or what went wrong. Now, enough theory, let's have a look at how this works in practice, and we start with getting the first thing out, and that's versioning. And the first thing that you shouldn't be doing, let's open Logseq, is enabling version control. So why shouldn't you be touching this? And that's a very important one, because if you do, Logseq does something which I consider weird, and there's probably good reasons for it, but it's like constantly mucking about. One of the reasons for that is, if you look at the directory itself, is that instead of a directory, I would expect a .git directory, you get a .git file, and that .git file, if I do a .git, then has a directory that's part of Logseq itself. So if I go to Explorer, I get this separate directory, and that has my Git configuration in it. This is not what you want. And the main reason why this is not what you want is it makes it really hard to go to that terminal and then run Git commands here. Because if I do like Git log, it just says like, I don't know where Git log. So this is absolutely horrible. We're going to reset that. I'm going to remove that Git directory, or let me first go towards Logseq, go to settings. I'm going to go to version control, allow Logseq to complain about it. And then once this is done, I'm going to go to that prompt again to make sure that there's no .git directory there. It's empty. And I'm also going to go to that Explorer page here. I'm going to make sure that this directory is gone. So this is like in my home directory, .logseq.git. I'm going to go Shift-Del, remove everything. Let's show how to properly do this. So what I do is I go to my nodes directory. This is here. And I'm mostly going to show stuff here on the prompt. There are graphical user interfaces for it, but if you need a graphical user interface, then I'm already going like, okay, be sure what you're doing, because using Git is like with great power comes great responsibility. So understanding what happens is very important to keep your files secure and safe. I'm going to do a Git init, and what that does is it will make that Git directory instead of a file. So now I have to like ls, I have to go into the file, and then you see the technical side of Git, like the database that it uses. And then if we do Git status, it says like, hey, I see files that I don't know. So I'm going to do that. I'm going to add dot. That means that I want to add the current directory in all subdirectories. So I'll go to Git status again, see everything. I do a Git commit, and M is the message that comes with it. I'm just going to call this init. And the moment I do this and I do a git log, then it says like, hey, I see the first change here in it, and that just adds the initial files. Okay, so I moved the graph a bit. That was because I was trying to demo the Git thing, but if I had it under my Ubuntu subsystem in Windows, then Logseq got confused. So I moved the graph back to my notes, which is in my local Windows folder where Logseq reads the files. So what we did is here in settings, I set version control and I enabled it after I made this directory. Then I made a quick test here and I just waited for a bit. And then if you wait for a bit, you get this. And this shows you like the initial change that I added. And then the one after is auto-saved by Logseq. So that's like the change. And then I can also do like a git diff, and let's do a git diff with this one. And then you can see that in the journal file, testing was added. So now if I make changes in my journal, let's make another. So I'll go here and say another change. Then eventually it should show up here. So we have one. I'm going to go watch the git log, and it should pop up like another change in about 30 seconds. So I'm just going to go wait for that and see if it happens. There you have it, out it pops in. So I put it like on 30 seconds right now. Now, if you're going to use this for any type of serious version control, I would highly recommend making this a little bit lower, because the log is always the same. It's always auto-saved by Logseq. And that means that it's very hard to find out like where did the change happen. I would personally have this at about 3600. They luckily increased it. That means that you get like one full commit per hour, or when you're closing Logseq. Now that we have Git set up and enabled, you should be able to see versions here. You click here, view page history, and there you see like the different commits that I just showed, the auto saves, and you can click one and then say like, hey, I would like to revert to that old version. So in this case, you can use it for version management. You can also, of course, fully do this within Git, but I do recommend considering the auto commit in Logseq, that if you start messing around in here, making any changes, close Logseq first. Just, get the notes directory the way you like it, and then restart Logseq. Because if you try doing it while Logseq is in, then you might be halfway through a change. Logseq will do an auto commit, and it's all going to be really, really messy. So either do the version control in Logseq or close Logseq and do the version control locally, because, else they'll start biting each other. But now we have like this basic setup. You have versioning, it's local. You can see it both inside the directory because you'll be able to do like git logs. This is enough to get started and to start working with the versioning. Let's see how we can use that to backup. So now that you have Git versioning, you basically have everything set up to make backups with it. And the only thing that we're really doing with backups is sending those changes to another Git instance, and those could be anywhere. Now, before we do that, you need to know that there's two ways of having Git. One is Git regular, so you see the notes and that .git directory that I just shown, but you also have something called headless Git, and that just means that you see only the stuff that's inside the .git, but no local files. This is usually used when you like put it on a server where you're not going to access it with Logseq, but you just want to have that database there and no local checkout. How does that look? So let's say you have your changes and you want to send those over to like different Git branch. And then the thing that you need to know is that there's multiple places where you could do so. Now, the simplest one is this bottom one over here. That is an USB stick or drive. It could also be another folder on your system, though that one's less useful. I am going to do it in the demo here, but you can also imagine me just sending it to like a USB stick to have like an actual backup, or sending it to a different drive. Then you could send it to the cloud, so upload it towards like a storage or a drive or a setup. Do remember though that as with all of these methods, encryption isn't included. Git isn't meant to be encrypted, it was meant for open source. So you need to set up some type of encryption on all these solutions. Encrypt your drive, sync to it, encrypt whatever storage you have online, sync towards that. And the last one, and this one is like another computer. So say you have like two systems on your network, you could send it over to another computer, and then Git is very flexible. You could do it in all these different types of ways. Now, I'm not going to be explaining how to do it with SSH, which is a possibility. There's, I think, a special Git protocol, though we don't use that very often because of it's less secure. Using another folder, which is going to be easy, and that's what I'm going to be demoing here. You could also be sending it to something like GitLab or GitHub, but also there, keep in mind that those aren't encrypted at all. So don't put any special notes there that you care about a lot. It is good enough for some casual notes. Just remember that, you know, the people at GitLab should be able to read it. And as long as you keep it on private, you should be fairly safe. Just know that it is readable and not fully encrypted like some of the sync solutions do, like Logseq Sync. Okay, so you have your local Logseq Git and you want to send it somewhere. Then you would think that you just need a directory and push it there. So let's make like a directory and call it backup. And I'm just going to try and do like a git push the backup. And then it says like, oh, it has no upstream branch. I don't know what to do with it. Just make sure that it's set. And the reason why you need this is because Git needs to know which branch to push to. So for example, if we're looking at the slides that we had here, these ones are branches and those top ones are like places where it can keep going. And you're trying to sync between this line, one line, and that line. Now, you don't notice that a lot when you're doing Logseq versioning because it's only one main line, but because this capability is there, Git will complain about it. So we need to tell it to go from this line, which is master, to this one, which is also master. And keep in mind, probably running an old version of Git here, because in the modern version, this should be main and that one should be main as well. Let's see if that whole command that we see here works. And then it fails because it says there is no remote repository, and that is correct because we haven't created a repository yet. Let's do that first. I'm going to go to the backup directory. You see it's empty, and I'm going to do like a git init. It's headless, but I'm not sure. Bear, that's the name. So if I do bear, then you have this, and this is just the database. This is the headless thing, what I was talking about. This is meant to get pushed towards and not to be like used. Normally, if you want something used, you're cloning it from somewhere. This is a place to make something where you want to push towards. I'm going to show you later how you could turn it into like a setup, but for now, we're just going to use the bear for backups. I'm going to go back to my main directory. I'm going to try and run that push again. And now you see it works. A branch has been made inside that directory. Keep in mind, this only works if you did like a clean Git directory where you're pushing it towards. If that directory already has something else that's pushed towards it, it's not going to work unless it's exactly the same setup. This has to do with how Git works. Git expects to have all the changes starting from a 0. If there is no 0, or if there's a different 0, so there's a 0 and then there's different changes, it has no idea how to combine those things, and therefore it will fail because it does like, I'm not sure how these changes fit with these other changes, and I give up. Now, if we go towards our backup and I do a git log in here, you will see that the same changes are here as well, but the data isn't there. Now, if you want to get that data, you would have to clone it or try to turn a headless Git into like a normal Git. But the easiest way to do it is to clone it, and that will be the most surefire way. So let me give you an example. I'm going to do like a git clone, taking backup. I'm taking that backup directory and I'm going to give like example git notes. And then it says cloning into example git notes. And if I go to that directory, then you see your files are there. If I do ls minus la, so I want to see everything, also the hidden files in this case. There's a .git directory, the same logs are here, the same files are here. And if I do a git remote, it will show that it got it from the backup directory. Now, we'll be getting back to these ones when I talk about syncing between systems, but for now, know that this is how you turn like a headless setup back into code. These things are all chatting with each other, and I need to explain that at some point later in the video, but for now, I just want to talk about like, hey, how to push those backups automatically. So you did this whole setup, but we're not there yet, because if I go to git remote -v, it doesn't say that there's any remote, and that means that my local nodes don't know about this remote directory where I want to push my backups. The first thing that we need to do is do like a git remote add, say backup, and point that towards the local backup directory that we had. So I'm doing this. Now if I do git remote -v, that's good. And then I can say git push and send it to backup. And then I will say everything's up to date. Now we need to auto sync it towards the backup. So here we have the Logseq Git Sync 101 page, which is excellent. It contains a lot of things that you could use to get syncing set up. There's also a lot of details on like how to get it working on things like iOS, Android, but mostly I'm coming here for the hooks right now. So if we go towards the code bit, it says Git hooks, and there's a post and a pre-commit. So that means those two things are going to help us. So look at the post commit, then you see here git push origin main. Now, as you've seen, I had an older version, so mine's going to be origin or like backup and main, but we're going to be adjusting it soon. And then there's also the pre-commit. That means that before it's committing anything, it's going to do like pull. It's going to try and get like the latest version from your backup. This is useful because with Git, if you would like commit code and you would commit code somewhere else and you would never pull, then you will start getting conflict. So we're going to be using both scripts. I'm going to go see if I can just download those straight away or just copy it raw. Let me get this one in, copy it here. And I'm going to go here and make like a pre-commit, put the file in there. You can do exactly the same with like an Explorer setup. So if I have like my Git demo notes here and I go here to, so if I go to the Explorer and I go to like Git and then to hooks, that's like the same thing. So I got like here the pre-commit that I just placed here, and I'm going to do the same one for post commit. So let's see if I can get the file here. I got the post commit, copy, go back to here, paste. Now, I already know that this isn't going to work. And the reason why I know that this isn't going to work is if I look at the post commit, it's going to do git push origin main, which has nothing to do with my current setup. These are defaults, that would be great. But if I do a git remote -v, then you see that mine isn't named origin, but it's named backup. And my branch isn't named main, but if I go to like git branch, it's named master. So you might get a message that this doesn't work. Make sure that those two, like this one matches your remote and this one matches your, you're gonna go and say edit, then the post commit. And I'm gonna go change this one and call this backup and master. And then for the pre-commit, I'll probably need to do something similar. So it's going to do like a git pull, which is good. And it's going to do a git add -a. So that basically means that any files that are there, it's just going to be auto adding before it's committing. So anything that you uploaded, anything that didn't get added will be added as well. This should work. Now that these two things are in, the biggest question is, if I make a change in Logseq, will that be auto pushed to the other directory? I'm gonna go make this split up a bit. And I'm gonna go to my backup directory. I'm gonna do a watch on the Git log. So the bottom one will show me like any changes that were happening. I'm first going to test it outside of Logseq, because if I do it on Logseq, I don't get any feedback. I don't get any data. I don't get any tests. So what I'm going to do is I'm going to go touch a test file, do a git status. And as you can see, like there's no change here, but this is like the remote one. This is that backup branch that we were talking about. And it's going to say like, hey, this file's been added. So I'm going to add that test. I'm going to go git commit. I'm going to give it that testing auto backup. Now, if this thing works as expected, then this should show up here. If it doesn't work as expected, nothing will happen. There you go. So what happened here? Let's make this all a bit bigger and tell you what is happening. It sees here like, hey, it's going to fetch something. So it's fetched from the backup directory. It sees if there's any updates, probably not. And then it does the whole commit set and then immediately goes like, hey, I need to send me my changes to backup. So you see like master to master, and it sends that one changed file, that one change up the chain. What this means is that now I have like an auto backup solution, meaning if I change anything in Logseq, then it will commit, and then when it will commit, it will push. This will work fine if your remote is always accessible. So for example, if you're using like a USB stick and it's not in there while you're making changes, you might get error messages in Logseq because it tries to push and it says like, I can't push. You can safely ignore those if you're aware that your stick isn't there, because either you're not carrying the stick, because as soon as you have the stick and you chuck it in there and there's another change happening, it will catch up. It will get all those changes in there. But do keep in mind that this whole system depends really on that everything is available, and that if something isn't available, you get a warning. And the only thing that you need to know then is like, okay, is there a reason for this? Is my internet disconnected? Is the stick that I'm using as a backup not there? In that case, it's not a huge issue. It will catch up later. But if things aren't working and the systems are there, you need to figure out why. And the best way to do it is to go out of Logseq, go towards the shell or towards whatever Git program you would like to use, and to figure out, hey, if I do a Git push, for example, what kind of error message do I get? So great, now we have this set up for like a local setup, and I can imagine that a lot of people, if we're going to talk about sync, which comes after this, they say like, okay, it's nice and all, but I'm not this technical. I don't have my own server running. I just want to send my notes to something like GitHub and not think about the fact that it's not encrypted over there, because like I'm just trying to get the sync working, and I'm fine with the fact that it's just private over there and it's working. So if you keep those things in mind, let's dive into how to set this up with GitHub. And with all the things that we've already done, this shouldn't be too hard. I'm very well aware that we're talking about a lot of technical Git stuff here, so it is not trivial. This is why I'm trying to go in depth and show all the commands and the things that I'm hitting. Hopefully it's good enough. If you have questions, do leave them in the comments down below. I'll be happy to like see if I can answer them, or maybe even add like a second video where I'll dive a bit deeper into Git. So the first thing that I'll need to do is I need to go to something like GitHub. I'm going to use GitHub since it's the most popular one, but this will work for GitLab well and any other online Git stores. I think Bitbucket is another one that's been used a lot. I'm going to say a new repository, and I'm going to go this Logseq Git notes sync demo, using a really long name here, but that's because I need to be able to recognize it later on. I'm going to say it's private because, you know, I don't want other people to read my notes. I'm not going to add a README file. I'm going to make sure that this one is totally empty, because if it's not empty, then I can push towards great repository. And then you will get these quick setups, and that's good because that's going to save you a lot of pain. Push existing repository from the command line. This is the one that you want, and this should work fine. The only reason why it won't work fine here is because I kind of on purpose changed the name so that you know what you're doing. First of all, let's going to get that added set up here. I'm going to go towards my demo. I'm going to go clear this so we only see the stuff that's interesting. And I'm going to go say git remote add origin, and then add the whole GitHub string. Nothing happens. That's normal because in Unix, if everything is good, then it doesn't show you anything. But we're going to go a git remote -v for verbose. Now you'll see that I have backup, which points towards my local backup folder, and I have origin, which points towards GitHub. This is good to know. What this means is that now you have like your backup and you have like your origin, and you can have like multiple remotes. Very cool feature if, for example, you want to say like, hey, if there is any changes, I want to push them to my like local backup drive so that I have like a local copy on like a hard drive or something, and I want to push it to GitHub for easy access, but I'm not trusting GitHub to always be there. So if GitHub suddenly disappears, I'll still have my local backup. This would help. Then let's do the initial push, and that's going to be a git push. Then what you see here, this says git branch and main git push -u origin main. As I told in previous setup, origin matches in this case because we're not sending it to backup, we're sending it to origin, which is the base name for like git remotes. And then main doesn't work because in my system I'm using master because it's an old git install. So let's go back here. I'm going to go push origin, which in this case, as we see here, origin is GitHub, and then I'm going to say master. I'm going to get like a message saying like, hey, you want to connect? I'm going to say yes. This check that it does here is for something called secure shell. It means that it checks like, hey, I don't know this host. Are you sure about it? You should get that at least the first time when you're connecting to GitHub. There's a difference in key, and that's because I haven't pushed a long time, and I'm aware that there was like a change in the known host for GitHub, but it's been a while ago. So if you get anything like this, if you get this later, you know, do a double check. Make sure that you know like, hey, why is this thing changing? It's for man-in-the-middle attack. Security wise, the good thing to know is that if you get this question first time, then it should be fine. If you get it later, double check your GitHub to see if it's happening. Here we see the whole push happening, and then let's have a look and see if our results actually came here. Now do a quick refresh, and there you go. These are my changes. And then if I look at the commits, then all the commits that we just had, see testing auto backup, manual add, all those things are here. And if I now make any changes in Logseq, will this sync to GitHub? That's one, but we also need to update our hook. So if we go towards that hook again, I'm going to git, and I'm going to go to hooks, and I'm doing like the host commit. I could change this to just send it towards GitHub, but I'm going to say, no, just send it everywhere. So I'm not only going to push it to backup, I'm also going to push it to origin, and I'm also going to push it to master there. There's like a double commit. And if I look here, you see like the change, and we're gonna wait Logseq out this time. Mostly because, you know, I want to see if it works even if I'm not there. So the version control, that one's connected. It has like auto commit on a long while. We're going to bring that down to 30 seconds. I'm not going to wait an hour for it to commit. and then see if everything happens magically. So I'm back on my Logseq Git Sync demo, and then if I do a refresh, it should show like a recent commit, and that is like uploaded. Now, quick note here, because in my case, I use an SSH key with a passphrase. If you have that, you need to dive into having like a SSH key agent running inside your Windows that runs before you start Logseq, else it will fail on pushing, but that's really out of scope for this video. If you want this to work and you don't care so much about SSH, the whole double security on it and stuff like that, you could generate an SSH key without a passphrase, then you don't have to worry about this setup. In all cases, be aware that you're like lowering your security for convenience, and that is always a trade-off, so be careful with your notes. So now I want to talk about sync, and I'll put a note towards the Git Sync 101 on GitHub inside the description, so you can look at that one, because once you have this whole setup, the whole backup, this is just the reverse. So it means that on some other place, you are going to clone this setup and then be able to open that and use it as notes. Let's keep this very basic, and I'll just show you how I get like a copy and how I could then open that in Logseq. First of all, I'm going to go back towards my GitHub in this case. I could do the exact same thing by cloning it from my USB stick. But for this one, let's use what is online, as I think most people will try this. I'm going to go to code, and I'm going to go take this URL, and then I'm going to go to like a prompt. Now let's imagine this is a second machine. So I'm going to go make their second machine. Okay, so I'm now on that second machine, and there I'm going to do like the git clone, and I'm going to go copy that line here, copy it, go back there and paste it in. And at that point in time, I have my nodes local, and if I do like a git status, nothing has changed. If I do a git log, I see like, hey, the last change that was uploaded. And if I do git remote, it should be filled in already. Now, the only thing that I should be expecting or maybe missing is in hooks. As you see, none of the hooks are there. I would need to copy those over if I want to have that auto commit send here as well. My recommendation would be to add those hooks inside your sync repository so you can easily copy them in. Let me quickly copy them from my previous setup to have like a complete set. Git demo, and then git hooks post commit with pre. And then here I'll need to change them as well, because if I go to post commit and I'm saying like, hey, I'm not going to send it to backup, I'm just going to send it to origin. So then echo tests, adding it to tests. So sync tests. So -a means that it auto adds tests, but out of habit, I just did it by hand, and M sends the message. This, you see that it gets committed and it gets pushed towards help, and that should be visible in here. If I go back here and I'm going to go towards the commits, and then it says auto sync test. So now I know that like this will be pushed as well. Now I need to open it in Logseq. So I go towards my Logseq. I'm going to go to Git demo. I'm going to say like, hey, I want to add a new graph, and then I'll get like a select folder set. Let's see if I can show that. And here I'm going to go, I'm not sure if this will work because I put it like in one of my local drives. Let me see where this is. Cheating a bit to win. Control C, back towards my select folder, Control V. So this is the directory that I need. Select it, and there are my notes, and those are then synced between two instances of Logseq. So if I make like a change here, it should like get pushed and pulled and then sent over. This way of syncing is always going to be more tricky than when you have like a setup that is done by an auto sync, because there everything will be inside Logseq and it will show you messages. In my case, like this is failing because there's like an old version of my setup site, so don't worry about that one too much. That's because Logseq gives me an error message for the other open instance that I have next to it. Using multiple windows while recording isn't the best. I think I'm going to set up a new system where I'm just use like a sandbox Logseq for these kind of demos. So now you've seen the steps, and I've mostly shown it on the command line. If you're not very fond of the command line, you can use any type of graphical user interface. If you look for Git on Google, there's plenty of options, and you have to find one that works for you. I mostly do it straight from VS Code, but that one's already like technical because it's for people that are writing code or scripting. But you could use, I think, Git Kraken was one that I used, but I think they got paid at some point. There's plenty of options. Have a look. I haven't tested any of those recently, but they'll at least give you like more of an overview and you can push it. Also, if you're using something like GitHub, I believe GitHub is their own client that you can use for this push-pull setup. It becomes a bit trickier on mobile, as mentioned before, because mobile doesn't have that same file structure that systems have, and they have a lot of security protection, meaning that one app downloading code from GitHub can't give those files to another app, in this case Logseq, to watch those. So you have to work around a few of those issues. This is where that Git Sync 101 comes in, where there's lots of details per system tested by people that are actually using those. I tried it on Android, where I used like the command prompt, which worked, but it was really clunky and I didn't like it personally a lot in day-to-day use. Told it works really nice on iOS by some people that are using it, but also there I don't have an iOS device, so I haven't tested it. So now you've seen the whole Git setup. This is already a pretty technical topic. If you made it to here, I'm assuming that you either are a developer or somebody that already works with Git, or you really want to know how to do this yourself. I would recommend, like, you know, watching something more in-depth about Git to get everything to know. The last thing is like how to deal with teams. And why is that important? Because, and let me show you my tablet here, is that if everybody works on a single remote branch, so assume this one is like on a central database server. So let's draw a server here. Everybody works on that one, then you're constantly are going to have conflicts. So like B made a change, A didn't have that change, so they're going to get like stopped. This is a lot of pain. You want to avoid that pain by having everybody work on one set. And the fix to this is pretty simple. In development sessions, and I'm assuming that somebody that wants to use this in a team has like developers, because else everybody has to learn Git, and Git is pretty heavy, is that you have feature branches, and you're doing exactly the same here. So you have like a master branch or a main branch that has like the collected nodes of everyone. So people clone from that, and then each one gets like their own, like Boss and Bob here. We basically get our own branch where we work from. And that means that we can work on those branches, we can commit nodes, we can make changes, and they keep going up, but they are centrally stored, so they're at least backed up. And then the only tricky thing is that at some point you will need to get those back to main. So one of the reasons to do that is where you do a sync with main. And how that works is that if you have like this setup that I just run, and I do a sync with main, so say main had like a few other changes, is that I say like, hey, I would like to get the changes from main, and this is me, and then this gets sent back to main. And so here is where some of that work happens. So like I'm doing like pull or like a merge from main, make sure that everything works with my node, and I push it and main is updated. And then somebody else would do the same thing. So if we take this main setup here and say that like Bob here was working on their changes, this is Bob's branch, then Bob gets to a point where he like merges those changes, and then this becomes the new main, and you keep working up that way. So everybody does their changes in their own set, and then once in a while they merge the main back in to get like the collective nodes, solve any merge conflicts, and keep working. The reason why you want to have these separate branches is because then you move that work, that trying to resolve conflicts, to like once a day when you want to merge the nodes. And due to the way Git works, this will usually be pretty quick, and there will be very little overlap. Nodes also are like a lot easier than code to merge, because very often you just want to keep both. So in a lot of these tools you will see like a setup where it shows like this is the change Boss made, this is the change Bob made, and you know which one do you want to accept, and you will say like both, and then both get added on top of each other. That works. This is not ideal. You shouldn't compare it with what happens when you have like Google Docs, where everybody works at the same time, or where you can like both take notes at the same time. There will be some merging, there will be some issues there. Another thing that I think is really tricky is how to do it with the journal in Logseq, because the journal is usually very personal. And one of the things that you could do is you could use a git ignore file and ignore the journal, and just say like, I'll put everything that is relevant into pages. Just keep in mind that you can't use stuff like block embeds then towards your journal, because whatever is in the journal won't be synced to the main page. But at least in that case, you have like your own journal, and you have some collective nodes or wisdom that you put somewhere else, like have a page for it. This is a bit tricky, because in my workflow, for example, I have meetings I keep like track of in my journal, and I couldn't be doing that. Then I would have to make like a meetings page or some setup like that to keep it working. Another way that you could have is have like a collective journal, but in that case, I would personally think that I would have like two graphs, like one personal graph with a journal in it, and one side graph for like a collective thing where we make like group notes in the journal that we know is going to get get combined. It's very dependent on your team and how you want to use Logseq. This is very tricky if you want to get this working, or if you're setting like up and going like, oh, I want to work with a team, I want to have this Git set up, but we're constantly hitting issues, then be sure to hit me up, as I can like have like a half an hour discussion to see like we can figure out a better solution. This is very technical. I'm really looking forward towards Logseq getting in the database version, because I know they're working on a way of working together, making this, you know, a pay to win kind of thing. If you pay for sync for everyone, then your problem gets solved for you, even though the nodes themselves are still encrypted and in your control. This, however, is like a good way to work if you need to combine some type of collective nodes or like a wiki. Initially, if you're doing anything like this, I would highly recommend making a second graph, playing around with that, testing it, seeing if you can use it like as a collective knowledge base. Tell people that, you know, it's okay to just copy their markdown files over into that pages folder to sync things up. And then after a while working with that and figuring out like what kind of issues you hit, grow up from there. Right, so this took me quite a while. It's a very technical subject. If you made it to this, then either props to you for keeping up with like me talking about this technical set, but it was really hard to make it understandable for everyone. I don't think Git is for everyone. You need to be at least familiar with the code set. If you looked at this and you still go like, I don't get any of this, thanks for watching till this point, like props to you. But you know, maybe either dive into like the basics of Git, so find some videos that learn you how to use Git, or use something like a file sync, like a sync thing, or maybe even just do it manually. That isn't bad. Like there is not a huge issue. I have a weekly task reminder to make a backup at my work, because I can't automate stuff to like a Git repository there. So what I do there is just like once a week, I run a small shell script that just copies it, zips it, copies it towards like a drive that gets backed up. So I have backups. Nothing wrong with like you having basic manual things for this, as long as you have a system that makes sure that it keeps happening over time. Still, again, any questions, be sure to let them know now below. I don't think this video is going to do very well, but that's fine. Remember, you're awesome. Definitely for sticking around till here, and see you in the next one.